Slime has fascinated people for decades, capturing the imagination of kids and adults alike. It all started with that iconic green goo in a trash can, a quirky toy that quickly became a pop culture sensation. Over the years, slime has evolved from a simple novelty into a global phenomenon, especially with the rise of social media. Today, millions of people watch and share mesmerizing slime videos online, drawn in by its oddly satisfying sights and sounds. But what makes slime so irresistible to poke, stretch, and squish? The answer lies in a fascinating mix of science and creativity. Slime is more than just a toy. It's a hands-on experiment you can make at home, using simple ingredients to create endless variations in color, texture, and even scent. In this chapter, we'll explore what gives slime its unique, stretchy texture and why it's so incredibly satisfying to play with. From the way it stretches slowly to the satisfying snap when it breaks, every aspect of slime is designed to delight your senses. Get ready to become a slime scientist as we uncover the secrets behind this gooey phenomenon. We'll look at the chemistry that transforms ordinary household items into something magical, and discover why slime is so much more than just a passing trend. Let's dive into the basics of slime, from its building blocks to the science that makes it so much fun. Whether you're a curious beginner or a seasoned slime enthusiast, there's always something new to discover in the gooey, satisfying world of slime. At the heart of slime is a polymer, a long, flexible chain found in school glue. These polymers are made up of repeating units, kind of like beads on a string, and they're what give glue its unique properties. When you pour glue into a bowl, you're actually working with a liquid that's full of these slippery, tangled chains, all moving past each other with ease. On its own, glue is runny because these chains slide past each other. To transform glue into slime, we add an activator, like borax solution or a contact lens solution, which links the chains together. The activator acts like a bridge, connecting the polymer chains at different points. As you stir, you'll notice the mixture thickening and becoming harder to mix. This is the magic of chemistry at work, as the glue and activator react to form something entirely new. This process, called cross-linking, creates a tangled network that gives slime its stretchy, satisfying texture. The result? A non-Newtonian fluid. Slime acts like a liquid when poured slowly, but feels solid when poked. That's why you can stretch it, squish it, or even snap it apart, and it always seems to behave differently depending on how you handle it. It's a perfect example of how simple ingredients can create something with surprising and complex behavior. That's the science behind the fun. A substance that's not quite liquid, not quite solid, and endlessly entertaining. When you play with slime, you're holding real science in your hands. Every stretch, squeeze, and poke is a chance to explore the fascinating world of polymers and chemistry, all while having a blast. So, next time you make or play with slime, remember, you're not just having fun, you're experimenting with the building blocks of matter itself. Ready to make your own slime? It's a fun and easy activity that you can do at home with just a few simple ingredients. Here's a classic recipe. Mix half a cup of glue with a quarter cup of water. Stir it well to combine. Then add borax solution 1 teaspoon at a time, stirring continuously until it forms a stretchy ball. The mixture will start to come together and become less sticky as you add more borax. Add food coloring or glitter for extra flair. You can make your slime any color you like, and the glitter adds a magical touch. Mix it in thoroughly to distribute the color and sparkle evenly. For a taste-safe option, try oobleck. Mix 1 cup of cornstarch with about half a cup of water. Add the water slowly, stirring constantly until it feels solid when tapped but melts in your hand. Oobleck is a fascinating substance that behaves like a solid under pressure, but flows like a liquid when at rest. Both recipes create non-Newtonian fluids, fun to play with and easy to make. These materials have unique properties that make them behave differently from everyday liquids and solids. Remember, always have an adult help with borax, and wash your hands before and after playing. Safety first. It's important to keep your workspace clean and your hands free of any residue. Store your slime in an airtight container to keep it fresh. This will prevent it from drying out and ensure it stays stretchy and fun to play with for longer. Whether you choose classic slime or oobleck, enjoy the process as much as the result. It's a great way to spend time together and explore the wonders of science. Slime making is hands-on science at its best. Experiment with different textures and see how the materials react. It's a fun and educational activity for all ages. Let's experiment. How does the amount of activator affect slime's texture? Start with your glue and water base. Add 1 teaspoon of activator. Your slime will be sticky and stringy. Add a 2nd teaspoon. Now it's stretchy and perfect for poking. Add a 3rd teaspoon. Suddenly it's stiff and breaks easily. Too little activator and your slime is a mess. Too much and it's rubbery. By adjusting the activator, you control the texture, stretchy, gooey, or firm. This simple experiment shows how ingredient ratios shape your slime. You're not just making slime, you're mastering the science behind it. You've gone from slime fan to slime scientist, learning how polymers and activators create that perfect squishy texture. With just a few household ingredients, you can experiment and customize your own slime creations. Try different colors, add glitter or beads, and see what new textures you can invent. The possibilities are endless. Each batch is a new discovery. Keep experimenting, and who knows, maybe your next creation will be the next big trend online. Stay tuned for more slime science and the latest viral trends.